It is a great pleasure for me to introduce our first speaker here with the technical content, Mr. Nick Milestone, who is a managing director of B&K Structures. He's also the director of the UK Structural Timber Association and director and chairman of TRADA, the Timber Research and Development Association in the UK. Among other things, Nick has led the UK's first national structural timber specification, which covers the design, manufacture and erection tolerances for solid wood construction. Interestingly enough, B&K Structures started off as a trading division of a company called B&K Steelworks, Steelwork Fabrication Limited, in order to meet, as I understand, the needs from customers seeking low-carbon sustainable materials. And I'm pretty sure that's kind of visible in the presentation by Nick. So please, Nick Milestone.
I was speaking in Oregon. There was 800 people turned out. That's relative to the size of the demographics and geography of the US of 350 million people. Sweden's what, 10 million? And you've got 600 people here. I think it's credit to you guys. You guys are seriously listening now. So, without further ado, we can kick into it. So please work. So close, guys. We're so close. Do you want to do it and I'll just talk through it? Can you do it up there? I've got my laptop in my room. There we go. Okay. So, BIM. BIM's a journey I think we're all pretty well familiar with, building information modeling. BIM is now going a step further to VDC, virtual design and construction. Build it twice. So what's driven mass timber in the UK? Well, it was an idea I had in 2006, December 2006. Sat in front of a client, you may be familiar with them, Tesco's. They wanted to convert their store program from steel to glulam. They couldn't afford it. We created the hybrid model. It worked. And we went on this timber journey, understanding carbon sequestration, the fact it uses a lot less energy in manufacture. But then you start getting into the realms of CLT, and you start seeing other things, air tightness. So you're actually affecting the carbon in the building's lifetime of operation. We know it weighs a lot less, but you know what? We're starting to see other impacts. It's dry, it's quick build, and it looks and feels a lot warmer. There's the well-being discussion. We've all seen the case study on well-being. Timber's hygroscopic, it breathes, it exhales moisture, it's a sense of well-being. So the market sectors, I'll try and give you the case studies. During the recession, we had to create a business model that could adapt itself to the market conditions. So wherever the capital is being spent, you have to be there. So the best place to go and be the backbone of our business is the education market. The education market loves it. The universities, they love it. It's a place to attract very respected professionals to come to the UK and work and study. So they started to build these pretty attractive buildings. And of course, we can do some nice, attractive geodesics. One of the nice ones we built was this one, the University of Nottingham. GlaxoSmithKline, a well-known pharmaceutical company based in Singapore for tax reasons, they wanted to do something right. And so they built the Centre for Sustainable Chemistry at the University of Nottingham. And there's the BIM model with the 4D and the 5D pulling out of it. But the fact you can start building these things in mass timber, not about CLT, but glulam as well. And they did it because they wanted the world's best professors to come to the UK to work, to attract international investment. And of course, these buildings are great. And I take a lot of tours around this building. This is not far from our offices. This is a great building to see. But the education market takes on other formats. Glulam, we all know glulam. It dates back in the UK to about 1862. We found this registry office in Southampton. But this is a good use of mass wood, of glulam, mixing it with steel, mixing it with concrete. And when you're a design and build contractor, what B&K Structures is as a specialist subcontractor, then we can take all these materials and build them together. Kindergartens, primary schools, even to more secondary schools, just using pure CLT and exposing the CLT for the environment and well-being of our children. And they can take on all forms and shapes. And CLT is often not seen because it is a structural stability wall. It's a great product in its own right. So you can see the kind of stuff we've been building in education. I like this one. This is, at the time, one of the biggest ones we built. It was about 2,000 cube of CLT. But we mixed it with structural steelwork. Now, steel, CLT, steel, and glue-lam is symbiotic. And what I mean by symbiotic, it's working to the same design, manufacture, and erection tolerances. Unlike concrete, concrete's got a mind of its own, unless it's advanced concrete off-site. But we can create, and steelwork plays a great part in CLT, you can create span. Shallow beam spans. And I'll show you that in the residential stuff we do. I like this one. It doesn't look anything attractive, but it's got all the accolades that timber can offer. So this is a steel frame, 2-story. It's got cross-laminated timber, floors and roof for the visual exposure. But the red panels you see there in the 3D model are the black panels you see on the building. And that's using glue-lam technology, basically taking stick build to an industrial size. So we can create dry envelopes inside 10 weeks. So that means the following sub-trades can work externally and internally concurrently. And that whole building took about 25 weeks to build. It was brickwork, that's what slowed it down. But it looks great. But you know what? It's what it looks like inside. It's being able to use the wood and expose it and create these lovely environments. And it actually kind of celebrates the steelwork, giving that sort of industrial look. We've been dealing with Google's new headquarters in London, and they're pretty much going down the same track of having exposed CLT in their floors at their new facility in King's Cross. The universities, they like it for its exposure. I show the connection details to show the symbiotic nature of mass timber and steel. If it fits in the model, it fits on site. It works perfectly. We're currently on site with this project. These are live projects. This is for Jaguar Land Rover. This is the National Automotive Innovation Headquarters at the University of Warwick. Now, they wanted a nice grid shell glue-lam roof with CLT decks, but that was not the success of the project. The success of the project, I'll show later on, is those big silver panels. That's our CLT through-wall system. We call it the mega panel. It's a CLT stability wall pinned against an RC frame, using cross-laminated timber. So this is about the journey of CLT. It's not just about exposing it and seeing it. This is about what it can truly do and perform. And it's a great material. And there you can see the big silver walls going up using cross-laminated timber, but nobody will know it's cross-laminated timber. So the residential market, this is what's gaining this serious traction in the UK. So we did our first one many years ago, Banyan Wharf, a very unique structure. And at the time, the developer didn't know how he was going to build it. It was under Hackney and Shoreditch local authority. They had a timber first policy. So we looked at timber frame, we looked at a pure CLT, but because of the design rotates 15 degrees every 2 stories, well, it's quite eccentric. So what do? Well, we did a frame analysis, we modeled it up in CLT, but guess what? We put a structural steel frame in there. This is where it's about using CLT in the right place with the right materials. And then, of course, thanks to the advance of BIM and IFC file integration, the industry foundation class, we can create these unique models. If it fits in the model, it fits on site, and we double-check it between Tekla and CADWorks. And, of course, not all our clients and contractors we work with are getting around to having federated models, so we generate 3D PDFs and show the interrelationship of all the materials during the construction sequence. And this is the as-built project before it got its windows finished off, so hopefully, yeah, the case study's working, yeah, it's good. So this took about 30 weeks in the ground for the frame contractor, the concrete frame contractor, to do the perimeter walls, the tanking, and he did the core at the time in concrete because it actually could have been a CLT core with staircases and service risers and lift shafts. Then we come to site and we start putting the CLT and the steel frame up. And this isn't accelerated by any more, but it took about 28 weeks with 1 crane hook and 5 guys to build this. And that was to build 42 apartments. The beauty of having steelwork in there created open span. But like any true Englishman, we sold out and they were all sold off spec in Beijing to Chinese owners, of which nobody can afford to buy these apartments, by the way. So it looks pretty good and we're proud to be a part of that, and that's the finished shots. And nobody will know it's a CLT project. Yeah, that's the beauty of it. It's no different to concrete. It's mass. Now, this one I thoroughly enjoyed. This building actually started out as a 4-story concrete building built over the Northern Line, the Underground in London. When the developer realized how light timber was, he got an extra 2 stories on the same plot of land. So he got an extra story of office and an extra story of residential. So he increased his sale value. And there you can see the use of steelwork. To celebrate the exposing the CLT, we put cellular beams in there so he could put his service penetration so he didn't have the need for a suspended ceiling. But we also put a solid wood lift shaft in there. And one thing you learn about timber as you go on your journey is you've just prevented a great health and safety issue there. You've reduced the issue of silicosis coming from dust from drilling into concrete because you're drilling into timber. You're putting your coring it in with the spacks and the rotoblast screws that the guys are outside have seen this morning. It works. The lift shaft guys, they love solid wood because it's a stable product. So as well as being able to celebrate the timber in the office on the top floor because there's no fire loading, he exposed the soffits. And he proved that he got an extra 15% additional rate of return on that construction compared to a concrete building. Now that building there, you see, only took us 6 weeks to build. So that was dramatic on the program, and he didn't have the issues with the foundations. So Dalston Lane, working with Andrew Waugh, if anybody knows Andrew Waugh, great friend of mine, and we swap and share presentations, so there's a little bit of his in mine and mine in his. We speak together. So had this building been concrete, it would have been 10,000 tons of concrete, but it ended up being just less than 2,000 tons of solid wood. That's a huge environmental impact on the transportation to site and the foundations and speed of construction. So it's about 16,000 square meters. It houses about 800 people. And we use approximately 2,500 trees, so we can pretty well quantify it. And that's the volume of material, just over 4,000 cube. We're dealing with a project in Bristol, which is going to nearly double that in size. But the client's really excited about CLT because now we've developed in a CLT through-wall system, so we can use the stability walls actually as the core component. So we saved about 7,000 tons of CO2 using the carbon sequestration argument. To quantify that, about 1 million kilometers of an Airbus. And I love this bit, you know. This is what we managed to save globally. That's the amount of energy that we've used and saved. And of course, being English, yeah, lots of cups of teas in there as well. So, you know, we can equate this to what we know in our everyday life. So there's the frame analysis model. And then, of course, there's our CAD model. Now, there's always an interesting challenge on every project. And this was pretty easy to construct. You see that big blank wall there? That's about 500 square meters. And that's against an existing boundary condition. And that was 500 millimeters away. So there's no way we was going to get scaffolding or people down that elevation. So here's the construction shots of it going up. Nice, very modularized on its layout, so we didn't have to put any form of glue-lam or steel in there to create span. And of course, this was the key to it. This was what unlocked the project. This is about taking a stability wall and making it into a through-wall system by putting insulation cavity membrane and using a Trespa-type finish. And these are the panels we put up. And it was just by simplicity of design. So when we dropped these in and we screwed them up, the rubber gaskets, they compressed, and that was it, it's finished. That was it, done on the outside. Because we took advantage of the lightweight material called CLT. So we've done quite a few. This is at the University of Cambridge, student accommodation, low-rise. Normally under 4 stories, you can get away with stick-built timber frame. 5 stories above, this is where CLT comes into its own. But people are enjoying CLT mass timber. This is another different type of student accommodation using beam and stick glue-lam and CLT floor decks. But then, of course, you can expose your glue-lam as well to get that more hygroscopic feel about the construction. So the commercial market, this is fun, and this is where the office London market is really embracing. So I'm sure you've seen this building quite a lot, the Sky Believe in Better Academy. To give you a picture and understanding of it, so I got involved personally in October 2013 when it was a blank sheet of paper. They didn't know what they wanted. It was originally going to be a temporary building. Then they decided to have an academy at Sky TV. But you know what? 11 months later, it was built, finished, and handed over. So that was pretty fast track because it used a dry build material called timber during the winter months. So we worked with Arabs who did the 3D modeling, the BIM modeling, and the M&E clash coordinated coordination and the construction. And this is the shots. So for me, it wasn't about the glue lam or the CLT, because, yeah, that could have been steel, could have been precast concrete. But again, it was those wall panels on the outside using glue lam technology for the quick build. That's what allowed the concurrency of construction. So it's always nice to have a time lapse so you guys can appreciate. So looking at the timeline, so this is around January, February 2014 on site, principal contractor Mace. They're preparing the ground. They didn't have to put any piles in the ground. It was purely built off a raft because of how incredibly lightweight it was. Then we came to site around March 2014. Here we are. We're pretty much rattling through with it with our glue lam and CLT frame. But this is where you start to understand where CLT comes into its own. We used it for the shear wall construction, so it was the spine of the building. So all the lift shafts, elevator staircases, service risers with a core stranded between a shear wall of CLT. We did put steel up there. We put a 5-ton truss up there to restrain the floor so it could have a column-free load on the middle floor. Now, it doesn't look very tall. It's probably about 24 meters in height, so it's probably nearer 6-7 stories because they're big buildings. But you see there, it wraps around them timber panels. That's what gave it absolute speed of construction. So effectively, the roofer, the curtain waller, the glazier, they all worked on the outside while they did the fit out on the inside. And that's what made it such a quick build. And it was a great journey because Sky loved it so much. You know, we got a lot more business out of that. We traded about £10 million just on site over an 18-month period, not just building the Believe in Better building. We then went on to do them a fitness centre because there's about 8,000 people on site at Sky TV. And I think we're about nearly there. We're good? Yep. Just about there. Wait for the ice cream van to turn up. And you can see how small the site was. You see that little area we had to build in. There's no scaffolding. I think we're about there. We're good? There you go, with the ice cream van. We're there. So that was it. 9-month build. From January, and the client moved in September. So again, it's taking advantage of timber. Great building inside. I run Sky tours. I take people from around the world to look at this building. But not just that building. Sky then said, crikey, we love timber. So we got a great order. If my Welven are in the room, we got an order for 7 kilometres of glue lam beams, 21 metres long, 2 metres deep. But it wasn't about the glue lam beams. That wasn't the success of the project. The success of the project were these things. These are timber roof cassettes. And this is using glue lam technology. So they're completely pre-finished with a metal tray liner, perforated metal tray liner for acoustic purposes. But we also put on the mineral felt. And there you are, dropped in. And we were landing these at about 600 square meters a day. It was landing in like precast concrete or metal decking. So it works well. There's no safety netting because we risk managed it out. And the guys just screwed them in with just big screws. So this is basic construction using timber. So this is how it looks now. And again, it's really well worth the visit. It's a fantastic environment for the staff to work in. They love it. Sky liked it so much. In their Mal area, they wanted a steel frame. We're using CLT floors, but exposed from the underside as their products. And that's how it looks. And it really is, you know, I do recommend you come and see it. It's about 16,000 square meters on plan. And it houses around just shy of 4,000 people in that building. They wanted a gymnasium, so we did. So we built them. We were originally going to be 3 stories in CLT, but this is where we said to them, no, you've got the dynamic frequency of a dance class next to somebody having a massage next door. You should really change it. So they went first floor concrete, 2 stories. But this is the beauty of BIM. You know, you can actually put in the health and safety issues, your acro props. So you can de-risk it out under CDM, construction design management. Now, I'll just go back one. This building is extremely unique. We developed with Arabs and DRMM, the architects, the world's first flat beam. If you imagine a steel beam or a glue lam beam as a downstand, we rotated it horizontally for a near flat soffit. Against CLT, that's where you see the dual columns because of the sheer rotation of it. And it looks absolutely fantastic, and the Sky people love it. A lot of municipal buildings. This is, for me, a great use. We use a steel frame with CLT, using it as the bracing action for the horizontal and vertical dynamic action. But we mixed it with precast concrete for thermal mass. So if you can see on the picture on the bottom right, you can see a CLT with a precast concrete. And we learnt a lot from that. Concrete has its own tolerances. Concrete just wants to do that. CLT and steel is within 2 millimeters. We had to overcome those issues, but you know what? Bath and North East Somerset Council, they absolutely love the buildings. A lot of swimming pools, it's perfect material for it. Even Woodland Trust headquarters. I always show that picture on the bottom right because it looks complex, but it's not. It's very simple. It fits in the model, fits on the project, fits well. Earlier projects down at the Olympics, 2012, London Bus Garage, they wanted a mixture of spruce and larch. Even to more recent stuff around the UK, using markets with geodesic technology. And this one, Pinewood Studios, right near Heathrow Airport. We built, if you can see on the top right, there's the James Bond soundstage. And we were under tremendous pressure to build the first phase of 5 buildings, because Star Wars Episode 8 literally moved in the day after we finished. And it was great. We saw the Millennium Falcon, but we all signed an NDA, so we couldn't tweet the pictures, which is really a shame, because we look pretty cool. And it is big, by the way, the Millennium Falcon. And so this is how it looks. It doesn't look anything exciting, just looks like a big tin box. But that's the true secret to it. Effectively, we did huge glulam panels, about 14 meters long, 3 meters wide, completely pre-finished internally and externally, even down to putting in the gutters on the roof. And each of those buildings, well, we clad them in 5 weeks. Again, because big panels, the use of timber, it worked really, really well. And that's what a soundstage looks like. It's nothing exciting in the film industry. It really is smoke mirrors and green screens. Okay, so the sports and leisure market, of course, you can have your big glulam frames. This is Centre Parks. This is the last one to be built in the UK. The next one, I think you guys might be familiar with Centre Parks out of Holland. We're building the next one in Ireland, 75 metres long, about 2.5 metres deep, and the client wanted it painted white. This was larch, painted white, which is, I refused at first, but he paid me a lot of money and we did it. And but what you can see is the interrelationship with steelwork, and thanks to modelling, we got over that quite easily. And believe it or not, we put that frame up in 5.5 weeks. So, you know, this is, you know, using timber in a great place. And of course, you can do some extraordinary things with timber. You can create the geodesic structures. We only needed 5 props on that job because timber's so light. Of course, the connections actually were heavier than the beams. The connections are about 1/2 ton each, using captive nuts, so you didn't see any bolts. And it was a great building. Where we started from 11 years ago was the retail world. So we built 32 Tesco's, 8 Sainsbury's, 2 Asda Walmarts and a Marks and Spencer's. And that's all testament to the retailers, and the biggest one we like to show off, which was a great balance. This was 10,000 square meters on plan. We had 10,000 square meters LVL on a glulam frame, on a steel frame. And then we had our curved glulam arches, and of course, steel allowed it to stand up. And that's the beauty of timber and steel. Using timber correctly, we can protect the steelwork in a fire. In a fire, steelwork will yield after 15 minutes. Well, the size of the glulams we use, they'll stand up for 8-9 hours. So this is why the fire brigade in the UK like mass timber, because it's predictable under fire. So we've done a lot in pine, we've done a heck of a lot in spruce, sorry, and done a lot in larch as well, on a lot of retail parts. So we've been pretty blessed being able to build what we build. This isn't a very big building, but I love this building. We put this building up in 4.5 days. And this was using CLT as the core stability wall with some glulam beams and exposed CLT in the roof. And you know when you've come so far in your journey, because if you look at the picture in the bottom left, and it really is wet and rainy in the UK. I mean, if you're going to test wood, build it in the UK, you get horizontal rain there. And if you look there, it looks like a swimming pool, but we got the detailing correct. We got the Rotoblast airtight tape, and I'm not promoting Rotoblast, but they perfected the tape for us. Not one leak on that roof. And we have a simple philosophy. If water can't get in, air cannot get out. So it works well. And it's such a shame they didn't expose the CLT, just the glulam beams. And that was just a little fast food eatery. So the kind of stuff is important. And this is on our journey. We've got the chain of custody, PFC, FSC. It's more PFC in Europe. Trada, we do a lot of publications. Structural Timber Association, we do a lot of publications. But build off-site. We're now working with the insurance industry, especially in the residential market. So somebody's buying property with a 25-year mortgage. It's not about insuring it for the first 12 years or the 25 year of the mortgage. We've got to make sure that these buildings last at least 60 years, because At the end of the defects period, nobody's going to expect to have the building ripped down because it's gone rotten because it's wood. So we have to make sure the detailing and the construction is robust. I've just put that Rossborough Award in, by the way. I'm very passionate about health and safety, and proud to say I'm going to Buckingham Palace on Thursday to receive an award for our commitment to health and safety. It doesn't matter what you're building, by the way. But the stuff we've done with the Structural Timber Association has been great. We work with the UK Health and Safety Executive. Because it's timber in construction, it is susceptible to fire. 99% of all fires on a UK construction site are arson-related. So we developed the 16 steps to safety. And this is just about very basic, pragmatic safety steps to ensure that it's the prevention of arson on a building site. And that's taking into account the boundary conditions to existing buildings. But more recently, we've just done our Guidance Note 14, which is the robust detailing of cross-laminated timber. This is about how to detail it, working around other materials, to ensure that over the lifespan of the building, moisture cannot come in through the roof or the window apertures. So we just got it signed off by, hopefully, NHBC, the National House Building Confederation, which is our largest UK insurer for the residential market. We've got a lot of off-site publications. The RIBA, the Royal Institute of British Architects, have just done a DFMA overlay of their 2013 plan of works. You may or may not have heard of the Farmer Report. It's like Latham and Egan. It advises UK government. It's explaining we've got a skills shortage, we've got Brexit. Brexit's an opportunity. Off-site is how the UK going. But all the developers think, well, if we don't going to build on-site with traditional materials, we should go straight to 3D build, which is volumetric. But you know what? CLT is the halfway house for 2D. CLT can be used in volumetric, but it's better used as a flat pack construction. And I'll show you that. So as Trada, really proud, we spent 2.5 years developing the NSTS. So in the UK, we've got the National Structural Steel Spec, we've got the National Spec for Concrete. So we felt we should platform timber. If timber's going to compete with steel and concrete, it should have its own national specification. And we produced it. We're now on version 2 because we've just accommodated hardwoods. But it takes account of not just glulam and CLT, it takes account of stick-build, open-close frame timber panel, and LVL. So we really have sort of got a measured document. We've done some other great stuff. Hybrid construction, mixing mass timber with concrete and steel. Structural timber elements. One thing we have got a shortage of, not just in the UK but everywhere, structural timber engineers. Structural timber engineers unlock mass timber. I've been blessed. I've got 5 of them in-house. I've probably got more than Arabs and Borough Happold in the UK put together. But you know what? And these guys know the worth, trust me. So we decided to get a book out through Trada that will help any budding young engineer want to design in mass timber. We've done timber engineering with BIM. And more recently, we've had our own CLT handbook, which we're going to evolve. The second version will come out in October at EcoBuild. So I'm just conscious of time. I'm within 5 minutes. That's good. So applications of mass timber. So a Swedish company, IKEA. Well, guess what IKEA are up to? This. This is IKEA, or what is now known as Vastint. IKEA into hospitality. So anybody who knows somebody who works in IKEA, and I'm sure you do, my wife works for IKEA, all their pension monies, they go into the development of a lot of buildings across Europe. And Vastint have taken on a project, 50 hotels for Moxie, which is the budget brand of Marriott. So they did a life cycle assessment of all volumetric construction involving steel, concrete and timber. And guess what? They went for CLT. Working with Binderholz, they're producing volumetric wet rooms, back-to-back wet rooms. But they're also using 2D technology. So if you look at the pictures on the bottom, they're taking the internal walls and the external walls prefabricated off-site with all the M&E, the insulation. And then the bottom right, well, they're putting these hotels up in record time. They're building 20 alone just in the UK, predominantly around airports. But they're now entering it into the UK student accommodation and residential market, where it will be pretty much rolled out. Prefabricated walls, using mass timber, the CLT walls, hybrid construction, the interaction with steel and concrete. But guess what? I love this one. Nothing big, but it's a service riser using CLT. We call mechanical electrical the neglected child in the UK because it's all built in situ. Well, let's start building MEP off-site. So we took a heck of a lot of CLT up to Newcastle, where we sub-assembled floors, boxes of cross-lamp, and they pre-fitted out with all the M&E. Then we went to site and we dropped that in a day and a half. So again, this is taking advantage of the lightweight material called CLT. And where we are right now, this is working with our partners, Rubner, where we can start developing through-wall systems with CLT. A pinned solution against, say, a concrete or a steel frame, but equally use it as a stability wall as well on cross-wall construction. So it really is that possibilities with CLT it's absolutely endless. Now, it's up to you guys. I've got 2 minutes left before we finish. I've got a case study, 2 minutes. Do you guys want to see it? Yeah, why not? Okay. Okay, Thomas. Is it working? Or did you take it off? There we go. You got the sound? Turn the sound up. I don't want to talk for 2 minutes, trust me. Ah, you've got it. Okay, so thanks to Google Translate. Jag hoppas att du haft min presentation och tack.
Thank you very much for a very interesting presentation. I think we should take the opportunity, if there are any questions from the audience right now, you have the chance. Any questions to Nick about his presentation, about his experience, about UK conditions, or I don't know what? Anything? Almost.
Almost. Oh, wow. Okay. Not many. We have Scotland, Wales, southwest England, and we've even got, like a wood for good equivalent, we've got Grown in Britain, who are trying to get English timber into the supply chain, but we do not have the quality control or the conditions to kiln dry it. Because one of the beauty of mass timber when it comes out of Austria is the fact, or Germany, is the fact that it's kiln dried to +2 or -2% equilibrium. So it's around 12-14%. You can't guarantee that with timber in the UK. Timber in the UK does have a preservative applied for the stick build market, and we're working with the Austrians right now to get preservatives applied to satisfy NHBC. Going back to your original question, we do not have sufficient volume. We're quite a moderate climate, so we're warm summers, mild winters. I haven't seen snow in the UK for 2 years now. So it's a very quick growing material, and it's just not good enough for engineered wood.
Any other question?
No. 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 Sorry, say again.
The question was why seemingly no weather protection is being used during construction.
So how we get over that is we simply seal the end grain. The end grain on wood is like straws, so you've got the capillary action of taking in the moisture. So off-site, we apply a wax coating at source. Stora Enso, they're very good at that. And when we construct with it, no moisture penetrates the wood. Moisture will sit on top of the CLT, and you will get a minor scalloping of a 2 mil deviation, but you take that into account when you're engineering the timber, otherwise you'll end up with creep going up the building. So, but yeah, pretty much, it's not really an issue. And to be honest, the way we put the detailing together on a half-lap joint, and I can explain it now, we run a beader mastic, we put the sealant tape down, we put the cover plate down, we screw that down, 2 more beads of mastic, and more sealant tape, and pretty much it is watertight. So but it's taken a few scars to get there, trust me.
Okay. I have a question for you as well. From your experience in the UK, and for sure you have some overview of other countries perhaps,
yeah.
What would you say, is there any particular application or way of using the cross-laminated timber in the UK which differs from other European countries or Sweden, for instance?
No, it's to be honest, we get our mass timber from Stora or Binder. KL-trä are present in the UK, represent KL-trä. But that's because they've got big capacity and they're manufacturing it at source from Central Europe, which is a bit bizarre because, yeah, I know you've got Martinsons who will be a great evolving company over time. It seems just bizarre that you guys are shipping your Swedish wood to the likes of Stora and Binder and then having to convert it and send it back again. We call that calls to Newcastle. We don't have that issue in the UK. There's no CLT manufacturing. CLT manufacturing is going to start with the head of Legal and General Homes, one of our big pensions providers, now going to address the UK housing crisis by building CLT off-site. And they're going to start manufacturing their own CLT, but they'll be using European timber, and the bulk of it will come from Sweden. So Swedish wood will get into UK CLT. But look at it globally as well. The whole global, I think, you know, Stora and Binder and KL-trä are in a great place because I'm beginning to see the traction of CLT globally. Everybody wants it as an alternative to concrete. Concrete has a high use of labour intensity on site. CLT is prefabricated panels. So the world is going mad for CLT. And I think there's going to be supply chain issues over 2018, 2019, until other countries start redressing the balance with their own CLT manufacture.
Okay. Thank you very much. Thank you very much for your presentation. Here's a small gift from our organizers on wood architecture.
Oh, thank you. Okay.
Thank you very much.
Thank you very much.